Alright, recording a little video here demonstrating Longfellow with the curb and drain. So this, what we're about to see is in Vistas. You're actually using two different versions of Vistas. Let's see. Well, maybe not. Maybe I'm only using 1.19. Some of this might be in 1.112, so it might look a little different. But what we're looking at here is the southern area of the Longfellow watershed, which this is actually the upper area of the watershed, so I guess you could think of it as like the headwater catchment, and the system flows north up through this gully right here, heading up towards the West Seattle Bridge and then to the Duwamish. The terrain is actually currently not exaggerated. Sometimes I have it exaggerated, so there's that 3.5. I'll leave it at 1. We're zoomed in so you can see some of the relief alright. And then this is not a hydrograph, this is rain along this axis here. My file format I don't think is quite right yet, because normally there's a bar that shows you where you're at on this x-axis, but this is just 1 year of data, so 366 days I believe, because I think there's a leap year in this year, 2020. Yeah, this is a little demo to show the drain issue, because Longfellow appears to be draining too much water through the pipe system. The reason I say that is that the scale is set to 1,000, so 1 meter, 1,000 millimeters, 1 meter of water. So there's a lot of water. This is spring though, but as you get over into here, you're going to focus in on a couple areas that are still lit up, which means that if they're still red, all the way up to day 250, so late summer, getting into August, it gets pretty faint, but there's still a little bit of water right there, and we're going to be able to look at 250 specifically here in a minute. So there's about a year. So if we look at Longfellow here, this is day 250, that late day in the summer. And what's interesting here is that these are the three, there's a couple random tiny pixels, but overall these pink to purple pixels are the main problem, main concern here. But it's interesting because here we have a very large parking lot and there's a lot of water being routed right along this roadway. So it makes sense, it is routing the correct direction, going slightly downhill along this roadway towards a drain. But this large parking lot feature, which is in VELMA, so all of this black, if you're a 0, which is 0 is black here, white is 1. If you're black, then you're impervious. If you're 0, you're 100% impervious. So there's a lot of impervious area right along this roadway here. Over on this one, another issue, there's not necessarily, well, there's a little bit of impervious surface right next to it. Also some over here. And then down in this example, higher up in the system, so the soil matrix probably has less water. But again, the whole thing with curbs and drainage is we're supposed to be dealing with surface water only. So let me turn these off. So these pixels are all heavily impervious, but that's expected with pretty much any road pixel. But the surrounding one's a little bit of impervious in the gray zone. Could actually, let's see, we have you know, these gray ones here are, oh whoops, looking at the wrong layer. There we go, so half. So a lot of these gray ones are about half impervious, if you're like a mid-gray tone. So those are the issues in late summer when we expect pretty much no drain disturbance action going on. Again, I'll go back to the Vistas video. Go back here, so we're in June. Let's go right before a rain event. There's a little rain event right here. slow this down just a little. So we had a couple minor little rain events going on, lights up a lot of the roadway, and then fades out going into day 250 right here where we're at now, and then starts to get lit back up during rain events in the fall. So working, but are we moving too much water? And back to this idea, I wanted to focus in on, so what are these values here? So if these are in millimeters, which is what I'm assuming they are, these are 10 meter pixels. Here we have 24 millimeters of water, 51, 74. Oh, and I should mention that these are water trans in, but the way the drain code currently works is everything is accepting 100%. So if there's water on the surface, it takes 100% of it. So trans in and trans out are the same value. 97, getting into the hundreds, all the way up to 131, and this pixel right here is 155. I need to assess these in detail because I'm wondering where. It's interesting to me that this is 155, yet this is 131, and this one is only 16. So, actually, while I have this on, we can check where we should be able to check where the drain is. Okay, so here's the actual drain map. Let's oops, let's get into a there we go. Okay, so that is a 1. And these are all 2s. Okay, so that's what's going on. So this pixel right here, oh, what are these? 3. Oh, I'm glad I did this. That's interesting. Let me go back and look. So I'll just translate it again so otherwise we can see, but 1 is a drain, so that's a drain. This pixel's a drain. A 2 is a pseudo drain, so curb. 3 is no solution. So the water being routed along here, put it in the wrong area the whole time, but still applies. There we go. So drain, it's a 1, 2. Oh, okay, never mind. These all have these are all curbs all through here. Okay, that makes more sense. So these are all curbed all the way down to a drain. And these are also curbed to this drain. It's interesting that this pixel is so high. It does have water moving down through here, but we don't see any at this time step. But there's also this forest right next to it. So another potential issue. So, maybe just to wrap out the video, I'll just play this one more time. Maybe I'll speed it up. Finish with the cool part. It is actually working though, and it does show that you're moving water. Actually, I'll zoom up in this neighborhood because it is cool to see up in this urban neighborhood here, very gridded area. If you look at this in like Google Maps, then it's all residential. Everything's fading away, but it is neat to see if you go slow and stop. You can actually see. You actually see it in the color fading that we are moving water in larger and larger volumes down streets. So this area up here to another area is interesting, that is often lit up in Longfellow for some reason. Still lit up right here. You can also play with this. So here this is showing up to 10,000. Slight fade doesn't mean that these are 10,000, but that's 10 meters. 10 meters of water is the max scale, and we still visually see just a faint amount of red in here. So quite a bit of water there. Back it down to 1,000 or 1 meter, definitely it's solid red, so it's at least a meter of water right there. That stays pretty consistent. Also though, it makes logical sense here with the hillside, but yet again appears that in Velma we're taking water that we shouldn't be. The drain code is having access to water on the surface that it shouldn't be allowed to interact with. Or maybe it should, but I don't think it should. Thanks.